Selection statements. Grouping statements. Commands can be grouped together by surrounding them with curly braces. In the below example, we have two println statements that have been grouped together because they have been surrounded by a set of curly braces. Scope defines where a variable exists. A variable will exist or be accessible in the curly braces it was created below its declaration. Selection statements decide whether or not to run a segment of code. They make this decision based on the result of a Boolean expression. That Boolean expression we're going to refer to as a condition in the rest of this unit. When a condition is true, the code in the selection statement is executed. When it is false, the code in the selection statement is skipped. Our first selection statement we're going to be looking at is if. The format for a single line if is if parenthesis condition parenthesis, followed by a single line of code that's tabbed over. When the condition is true, that line of code will be executed. When it's false, that line of code is skipped. The format for a multi-line if is if parenthesis condition parenthesis, curly brace, several lines of code, curly brace. So here the if is trying to decide whether or not to run the multiple lines of code in the following group or block. Here we have an example that makes a scanner for gathering data from the keyboard. It asks the user for an age, then stores whatever the user types in a variable called age. Then we have two ifs to make a decision on what we should print back to the user. So let's assume the user entered 5. Age less than 16. Is 5 less than 16? Yes. So we would do the line of code in the if. And we would print you can drive in 16 minus age. So 16 minus 5, 11 years. You can drive in 11 years. Then we look at the next if. If age, 5, is bigger than or equal to 16, it is not. So we do not do the next line of code. Assuming the program was run again and the user entered 32, we would say age less than 16. 32 less than 16? No. So we would not tell them a statement about how long it will be until they can drive. But when we get to our next if, 32 greater than 16, 32 is bigger than 16, so we get a true statement, and it would say you are old enough to drive. Here we're going to do an example. So here's a short little program that tells the user what their letter grade is based on their grade. So let's assume the user had a grade of 80. Is 80 bigger than or equal to 90? No, so it would not print your grade as an A. Is 80 bigger than or equal to 80? Yes, it is. So it would say your grade is B. Because this condition was true, we did the line of code. Then we go down to the next if. Is grade bigger than or equal to 75? Oh yeah, 80 is bigger than or equal to 75. So this is a little strange. Now it's going to say your grade is C. Now we say, is your grade greater than or equal to 70? Yes. So we'd get, that is a true statement, so we'd get your grade is D. Then we'd say, is grade less than or equal to less than 70? No. So we would not see F. But this output seems a little bit wrong. If you have an 80, your output shouldn't be your grade is B, your grade is C, your grade is D. Let's move into the next slide and we're going to talk about how to fix that. Here we're going to fix that problem with conjunctions. So, skip back on accident. So let's go back and write down that our grade is 80. Is 80 bigger than or equal to 90? No, so we will not see that statement. Is the grade bigger than or equal to 80? Yes, because the grade, in our example again, is going to be 80. 80 is bigger than or equal to 80. Is it also less than 90? Yes. So we get true and true, making true. So we would print your grade is B. Now when we get to the next one, is 80 bigger than or equal to 75? Yes. Is 80 less than 80? No. True and false make false. We do not do the below line of code. Is grade bigger than or equal to 70? Yes. 80 is bigger than or equal to 70. Is grade less than 75? No. 80 is not less than 75. So we get true and false. True and false make false. We do not do the below line of code. If grade is less than 70, is 80 less than 70? No. So we do not get the line of code that says your grade is F. Our next selection statement is ElseIf. First, I'm going to go through how an ElseIf works before we go through the format. ElseIfs must immediately follow an if or another ElseIf statement. ElseIfs are only checked if it's preceding if and the ElseIf after it were evaluated to false. The format for an ElseIf: else if parenthesis condition parenthesis, and then you can put a single line of code below that. Or if you want multiple lines of code, it is else if parenthesis condition parenthesis followed by a block of code. Let's see an example. This is the same example we looked at earlier, but I've changed the second, third, fourth, and fifth if to be else ifs, so I can see if it behaves any differently and how so. So I believe our last example we did grade 80, so we're going to write in grade equals 80. So our grade's 80. If the grade is greater than or equal to 90, which it's not, then do the below line of code. So we will not be printing your grade is A. Otherwise, if grade is greater than or equal to 80, which it is, then we're going to print your grade is B. So your grade is B. Then we get to the next ElseIf, and how ElseIfs works. They're otherwise check this. As soon as you find, see, we started off with if, ElseIf, ElseIf, ElseIf. As soon as one of them becomes true, we no longer check any of the other ElseIfs. So this ElseIf is skipped, this ElseIf is skipped, this ElseIf is skipped, and our output is your grade is B. Else statements. So an else statement may immediately follow an if or an ElseIf. ElseIf statements are executed when it's preceding if and the ElseIfs after that if were evaluated to false. The format for a single line else is else, then followed by a single line of code. Notice there is no condition. An else is, for all other circumstances, do this. The format for a multi-line else is else followed by a block of code. So we're going to look at that same example. And here we're going to say grade equals 50. So, is 50 bigger than 90? No. So we have to check the next thing. Is 50 bigger than 80? No. So we have to check the next thing. Is 50 bigger than or equal to 75? No. Is 50 bigger than or equal to 70? No. So under all other circumstances, if we have not found anything to be true yet, we will do the else. And our output is your grade is F. Now let's see what it would look like had our grade been an 80, like we've been doing before. So let me grab the eraser, and we'll erase everything out of here. Alright, so if we had had a grade of 80, we can go up here, and I guess I didn't need to erase the word grade. That's fine. Grade equals 8, 0. Is 80 bigger than or equal to 90? No. Is 80 bigger than or equal to 80? Yes. So we get your grade is, well, is AB. So your grade is AB. All right. Then we go to the else if. It says else if. Well, we've already found something to be true, so we do not do this. Else if. We've already found something to be true, so we do not do this. Else, under all other circumstances. No, because we found something to be true, and we printed something. So this is not one of the other circumstances that was not covered, so we do not see your grade is an F. Nested selection statements. It is called nesting when selection statements or loops are placed inside one of another. For example, if we wanted to modify our grade assignment to show you have an A or A+, we could say if your grade is greater than or equal to 90, do the below code. And inside our block, we have an if and an else if. If your grade is bigger than that was a copy and paste error. If your grade is greater than or equal to 95, you have an A+. Otherwise, you have an A. This section of code can only get activated if you're higher than 90. So having a 65 would not go to this else, because you have to have a grade bigger than 90 to go to this if and its else. So if the grade is bigger than or equal to 95, it's an A+. Otherwise, it's just a normal A. Ifs behind semicolons. When you first start doing selection statements, you're used to putting a semicolon behind every line of code. So a lot of you are going to accidentally put an if after you're going to put a semicolon after an if. When a semicolon is placed after an if, it is treated as a single line. It's treated as a single line if that contains only a semicolon. So let's see what that looks like. An example. If x is less than 4, semicolon, system.out.print A, else system.out.print B. Now what the compiler sees is if x less than 4, do the semicolon, which is nothing, so do the empty statement. Then right after the if, not inside the if, right after the if, we have system.out.println A, followed by else system.out.println B. You get an error. The compiler says else without if, because remember, an else must immediately follow an if. And if you see, here are the curly braces for the if, here are the curly braces for the else. This is sitting in between them. You can't put code in between an if and its else. So this produces error else without if. So you're going to get lots of funky things happening if you put semicolons behind your selection statements. And if you get stuck and can't figure out why it's behaving funny, I can help you. I can come over and help you figure out what the semicolons are. Yoda notation. Yoda notation is a term for listing the variable on the right of a comparison instead of the left. I always do everything on the left because that's how I've been doing it since '98. So it's hard for me to change. But Yoda notation is better. So x equal 5. This is saying, does x equal the value 5? In Yoda notation, it would say, does 5 equal the value x? It's the same statement, it's just reversed. Doing comparisons in Yoda notation helps prevent errors when working with Booleans. For example, if we have old equal true, the condition has to result in a Boolean. If you do old equals true, what happens is it says old become the value of true. So old becomes true. Then the if checks the value of old, which is a Boolean value and acceptable, and it is true. So this if always evaluates to true. This is not a bug in your program. Sorry, this is not a compile error in your program. You had meant to do 2 equals, but it's going to behave funny because it's always going to do the if, even when old is false, because it'll change old to be true, then evaluate old, which is true, and it will say, oh, I have a true condition. So this is unfortunate because this is a bug that's very hard to find in your program, because it is not a runtime error, it is not a compilation error, it's a logic error. So that means your program's working perfectly fine, it's executing, but it's doing the wrong thing. But if we had instead still messed up and only put a single equals, if we did true is equal to old, then we'd be trying to say the literal value of true, which can't be changed, becomes the value of old. Well, that's impossible. True cannot be changed to mean anything else. It's not a variable, it's a literal. So this will produce a compile error. So when that happens, you're not going to get something that's hard to track, your program won't compile. So Yoda notation is better because it helps prevent errors. When you see me doing it in class, I've been doing it forever, and it's hard for me to change, and I usually do normal notation. Yoda notation is better.